So we said that imaging planets is hard. We've only been able to take photos of a handful. Detecting them by their effect on other stars, that's more sensitive to the big planets than the small planets. It's also more sensitive to the close-in planets. And so it's not as good of an indicator as to a planetary system like the solar system. Even transiting tends to be favoring planets that are in close rather than the ones that are farther out. And so, because again, if a planet only orbits once a century, then that means that if you're looking for 5 years, the chance of seeing it go by is slim, and the chance of seeing it go around more than once is 0. So how else can we find these things? Well, it turns out there may be other ways of finding them. Star Beta Pictoris, nearby star, fairly nearby, has a dust disk surrounding it. Well, so what? Well, remember we get a proplet. Well, after the material all congregates into planets, there's still a lot of interplanetary dust left. In fact, our own solar system has a lot of interplanetary dust, and it's still left over meteorites and things flying around all over the place. So if you were to look at our solar system from very far away, you would see kind of an infrared disk around it. In fact, even in the solar system, different times of the year, you can sometimes see along the ecliptic faint glow that we call the zodiacal light, that sunlight reflecting off of the interplanetary dust in our own solar system. So it's possible this disk around Beta Pictoris is a leftover remnant of a proplet around there, and that would be possibly left indicative that the conditions there were just right to have planets. So that would be strongly suggestive that Beta Pictoris might have planets around. The star Fomalhaut, actually, if you block the light of Fomalhaut, on the left over here, there's a disk here that's blocking the light of Fomalhaut, and so in the infrared, you can actually see way out here kind of a donut region of icy things. We know it's icy from the spectrum of it. Well, gosh, Fomalhaut's a little bit bigger star than the solar system, or rather than the sun, rather. And so we've got the Kuiper disk around the solar system. Well, this could be something like a Kuiper disk around Fomalhaut. Kuiper disk is not really not so much a disk as Kuiper Belt, rather. Kuiper Belt is kind of like the asteroid belt, and the Kuiper Belt is kind of a big donut surrounding it. So this could be something very similar. Well, how did the Kuiper Belt get out there? Well, it got out there by planets migrating in closer to the sun and pushing out the icy things. And so that would suggest possibly there's planets in closer here. Again, we see the Kuiper Belt sort of things around lots of other stars, suggesting that possibly this is a very common sort of thing. What about Earth-sized planets? Well, Kepler found Earth-sized planets. Enough of them to suggest that Earth-sized planets are fairly common. Problem is, the smaller the planet is, the harder it is to find. The closer to the star it is, the easier to find. So that means we found some Earth-like planets, but they're not always going to be Earth-like. Okay, Earth-sized does not mean Earth-like. If you were to move Earth much closer to the sun, it'd be way too hot. It may be too hot to have liquid water. It may be so hot it pushes away the atmosphere. You put it too far from the sun, and it's not going to have liquid water either. And so again, it's going to be too cold for life. Astronomers sometimes talk about something called the habitable zone. If you're too close to a star, it's going to be too hot. If you're too far out, it's going to be too cold. Right in the middle, it's just right. And so we call that the Goldilocks zone or the habitable zone. Now, how do we define habitable zone? Well, on Earth, all life is based on the chemistry of carbon. So we need a solvent that's suitable for that. Well, water turns out to be solvent. Water is also one of the most abundant things in the universe. So that's a very good solvent. Life is basically very fancy chemistry, and so you got to move the chemicals back and forth to have life. And so you need a ready solvent for that. Readily available, water. Okay. Other things might work, but they're not going to be as readily available. That means any kind of life based on it would be very, very different than what we have here. Most common sort of thing would be to have water, though, and then that. And even those others, the conditions have exactly right to get liquid water, because water is so common in the universe. Then that would be the best place to look for life. So you want to be in the right spot. And so that's what we call the habitable zone. Now it's possible for a planet to be just outside the habitable zone and still be potentially habitable by the right kind of life. Okay. Now, every now and then in the news, you hear about an Earth-like planet being discovered. But if you actually go and look, it's not really that Earth-like. It might be the right size. It might be Earth-sized, okay, but it's not in the habitable zone. Or it might be in the habitable zone, but it's not the right size. Usually it's too big. Or it's in the habitable zone of a star, but it's the wrong kind of star. Okay. Could life survive around another kind of star? Well, maybe, but it's not going to be anything like life that we have here. Because if you're around a red dwarf star, these stars tend to be flare stars. They're going to flare up until you have this sterilizing sort of radiation that hits the planet every now and then. You're not likely to have surface life. Though there's been some speculation there may be a chemical adaptation that absorbs the energy, the flare, and protects the life. So that is a possibility, but it's no guarantee. Maybe life underground. The other problem is if you're really close to a star, you're tightly locked, keeping one side of the planet always towards the star, the other side always away. So that means one side's going to end up getting too hot, the other side's going to end up getting too cool. It's somewhat unlikely that life would really be all that viable in that narrow region right along the terminator, or the division between light and dark. It may be possible, but it may not. And so that would not be a particular Earth-like planet anyway. And so even on Earth, Earth was here for a long time before we had life, and it was a really long time before that life, developed into anything else. And so indications are you want to have as close to Earth as possible. And again, some of y'all might have heard NASA announced in 2017 a group of planets orbiting around a star. Telescope in South America found this star had a bunch of planets orbiting around it, and several of these were in the so-called habitable zone. And 4 of them were in the habitable zone, 4 of the 7. Now, the spectral type star is an M8. So it's obviously a red dwarf, so that means these things are going to be super close to it because it's a very cool star. In fact, these planets that are in there, now some of them are actually very close to Earth-sized here, but they're orbiting so fast, they orbit in just a week or less than a week. So it gives an idea of how close they are to this. So that means they're definitely going to be tidally locked. And so it's unlikely that these things are going to be particularly habitable. These are artist impressions right here, and I think they are very far-fetched impressions. Just my opinion, but they're certainly very wishful. But as far as these planets being a habitable zone, I think maybe some further definition of habitable might be required. And I know there are astronomers that are working on that, and there are some that are very generous in what they could define habitable, and others that are a little more stringent. A lot of the planets that have been found, particularly using the radial velocity method, are these hot Jupiters. Kepler spacecraft found a whole bunch of smaller planets, things that are probably rocky or icy planets, things that are more like Earth or giant Earths or mini Neptunes. That's because those are the things most sensitive to finding. Earth-sized planets are probably fairly common. So these rocky planets like Earth has probably are fairly common out there. And there probably are a fair number of planets in the habitable zone. That does not necessarily make them exactly habitable. There have been over 4,000 planetary discoveries. Over 2,700 of those have been in planetary systems, meaning more than one planet in the system. So 600 multi-planet systems have been found. Okay. And we are absolutely convinced that there's a lot more out there. There have been thousands of other discoveries that have not yet been confirmed, but it's very, very likely that there are far more planets out there than we have been finding because, again, all the techniques are sensitive to only certain kinds of things. And so it's quite likely that we're missing a whole bunch of planets. The radial velocity method definitely misses the small rocky planets that are in the right spot. The Kepler method works best for planets that go around pretty quickly because the whole transiting method, you've got to see multiple transits. And so that only works if you have multiple times a planet goes around while you're looking. And so that tends to favor close-in planets. And so we still don't really have the full technology to find an Earth-sized planet around a sun-type star. And we are very close, but we don't quite have that technology yet. So when we do, then we get a much better idea as to how many Earth-like planets there may be out there. So I would say whenever you hear it in the news about an Earth-like planet discovered, take it with a grain of salt.